All right. In our last video, we looked at writing inequalities and looking at how those are written and how those look as a graph and graphing those inequalities. We also looked at some word problems and how inequalities show up in real-world situations. Today, we're going to be looking at solving one-step inequalities. So very much like solving equations with one step, except instead of an equal sign, we have an inequality. Let's look at some examples. Solve the inequality and graph the solution. So again, we're solving, and then once we have a solution, we're going to graph that solution. First one here, we have x plus 12 is less than 20. So again, instead of plus, we're going to do that inverse operation, the opposite of plus. We are subtracting. We're going to subtract whatever number is on the same side as 12, or excuse me, the same side as x. So we're left with x. 12 minus 12 is going to give us 0, and 20 minus 12 is going to give us 8. However, instead of x equals 8, we'll have x is less than 8. If on an assignment, if on a test, if on a quiz, you write x equals 8, that's wrong, because x does not equal 8. X is everything less than 8, which means that there's not one solution, there is a multitude of solutions. And the best way we have of representing that solution, what values could x be? Well, x could be 7, 6, 5, negative 12. It could be a lot of different answers. X could be an infinite number of answers. And so we're going to make that graph. The number that we're going to put in the middle of that graph is the solution. So 8 is going to go in the middle. Fill in a couple numbers on either side. And then if we look, since x is less than 8, I know that 7 and 6 are less than 8, and every number in that direction. However, 8, the number 8 is not less than 8, so 8 is not a solution to this inequality, which means that we are going to have an open circle on 8. 7.999 is a solution, but not 8. Got another one here, same idea. So we've got d minus 5 is greater than negative 7. We use that inverse operation. I'm going to solve for d. Opposite of minus is plus 5. Plus 5. I've got d minus 5 plus 5 will give us 0. And then I've got greater than. And negative 7 plus 5 is going to give me negative 2. I'm going to graph that solution. So I'm going to make my graph. Remember, the bare minimum that I require is 5 lines on your graph. We're going to go ahead and put that negative 2 in the middle. We got negative 1, 0, negative 3, and negative 4. Remember to count correctly in the negatives. Negatives go in the opposite direction. So be careful that you don't go 0, negative 1, negative 2, negative 3, negative 4. That would be wrong. We don't count that way. And so we need to make sure that our negatives are going in the correct direction. It looks like this. Then we're going to graph. Now you've got a 50-50 shot here. It's either going to go this way or the other way. So let's see. It says d is greater than negative 2. I know that 0 is greater than negative 2. So my arrow is going in the correct direction. And it is not d is greater than or equal to negative 2. It's just that d is greater than negative 2. So we have an open circle. So solving and graphing. What I'd like you to do is go ahead and solve and graph these two inequalities on your own, and then I'll try it, and you match with what you have, and see if it works with the same with what I have. That wasn't a very good way of saying it, but you get the idea. So pause it, try it on your own, and we'll see how you do. I'm assuming you did it on your own. Again, I'm going to solve for n. Inverse operation, opposite of minus is plus. So I'm going to add 0.3 to both sides, and I'm going to get 1.2 greater than or equal to n. And then I'm going to graph it. And yes, you do need to graph it. I'm going to put 5 numbers on my number line. And I'm going to get then 1.2 in the middle. Now you can go by any scale you want. You could go by ones. You could go by 0.1s. I'm just going to go by 0.1s. So I'm going to go by tenths. 1.1 and 1.0. N is less than or equal to 1.2. I know that 1 is less than or equal to 1.2. 1.2 is greater than 1. And so I'm going to go ahead and draw my arrow. Now 1.2 could be a solution because we have that line there that says that n could be equal to 1.2. So a closed-in circle. The next one, inverse operation, opposite of plus is minus. But remember, the whole goal, that what we're doing is we're trying to make this 0. And negative 3/10 plus 3/10 is 0. Same thing here. If I want to make this 0, what I need to do is I need to add 3, because minus 3 plus 3 is 0. You could subtract negative 3, and that would be correct. But either way, we need to make sure that minus 3 plus 3 is 0. So be very careful with that, remembering what the goal is. The goal is to make this 0, and so it is not there anymore. So however you need to do that. $2.50 plus $3, 2.5 plus 3 is going to give me $5.50. And so I've got 5.5 is greater than t. So there's my solution. And if I graph that solution, here's my graph. I'm going to put 5 numbers, 1, 2, 3, 4, 5. I have that 5.5 is my solution. I'm going to go up by halves. So if you went up by ones, if you want 5.5, 6.5, 7.5, that's fine. I'm going to go up by halves. So I'm going to get 6, 6.5, I'm going to get 5, and 4.5. And then we're going to graph it. It says that 5.5 is greater than t, which means that all my solutions t have to be less than 5.5, which means that my arrow is going to go that way, and we have an open circle for 5.5. So look at what you did, make sure it matches with what I did, or at least you ended up with the final solution being the same and your graph being the same. Solve the inequality. So we've got an inequality here with division. Remember that it is a fraction. M over 3 is a fraction. It's a ratio. However, we can also look at it as division. So lots of ways to look at the same situation. I know the opposite of divide is to multiply both sides times 3. So I've got 3 times 2.4, which is going to give me something, 7.2. Come in tomorrow ready to either tell me I did it wrong or accept what I have there, but I'm pretty sure 2.4 times 3 is 7.2. And then I'm going to graph it. 1, 2, 3, 4, 5. 7.2 is my solution, so it goes in the middle. And I'm going through these kind of quickly, but once you get in the swing of things, once you kind of start remembering how to solve equations, the inequality is almost the exact same. It's just a matter of putting it on the graph now. It's a closed-in circle because it's greater than less than or equal to. And so since 7.2 is less than m, 7.2 is less than or equal to m, I know that all my solutions will have to be greater than or equal to m. Same thing here. We've got 3/4 r is less than 12. So if I'm going to solve that inequality, I'm going to have to do the inverse operation. So since it's 3/4 times r, you've got a couple options here. You can either divide both sides by 3/4. That'll work. Divided by 3/4. In which case you'd have to take the reciprocal of the second fraction. Or you can skip to that step and say, well, I know I'm going to have to multiply both sides by 4/3 eventually, times 4/3. And so if I do that, 4/3 times 3/4 gives me 1r. And 12 times 4/3, when we're going to set it up as a fraction, you multiply the numerators together, you multiply the denominators together, you should end up with 16 in the end. Double check your math, work through the problem, see if you get 16. I'm going to set it up that original way, just so I can confuse people as little as possible, but we're going to divide by 3/4, divide by 3/4, which gives me 4/3 times 3/4, and 12 times 4/3, there we go, which gives me my solution. R is less than 16. Now I'm going to graph it. 16 is my solution. And R is less than 16, which means my arrow is going to go this way. with an open circle. Try these two on your own, see how you do, and make sure to graph. All right, I'm going to assume that you tried it on your own. So if we're solving for k, we're going to divide both sides by 4 to get k by itself. I end up that k is greater than, not 7, k is greater than 6. There we go. Which means that when I graph that solution, 1, 2, 3, 4, 5, 6 goes in the middle. Fill in a couple numbers around it. Since k is greater than 6, I know that 7 is greater than 6, 8 is greater than 6, so my arrow is going to go that way. And 6 is not a solution. K is not greater than or equal to 6, k is just greater than 6. Same thing with this one. Again, you should have tried this one on your own. If we are solving for g, we have both those options. We can either divide both sides by 3/4 and then take the reciprocal and multiply, or we can just multiply by 4/3 and see that 4/3 times 3/4 is 1g left over. And if I times by, let's say 4/3, if I multiply those two fractions together, I should end up with 36. My mental math serves me correctly. G is greater than 36. Now I'm going to graph that. So we've got 1, 2, 3, 4, 5. 36 is going to go in the middle. I'm going to fill in a couple numbers around it. Again, you can always go with any scale that you want, unless it's a word problem. If it's a word problem, then your scale should make sense. But if there's no words associated with it, if it's not a story problem or a real-world situation, you can make up whatever scale you want. G is greater than 36. I know that 37 and 38 are greater than 36, and I know that 36 is not a solution. 36 is not greater than 36. Hopefully at this point the solving should be the same as chapter 2. You should be very comfortable solving. Now it's a matter of using that inequality and graphing the inequality. Last little bit here, Sammy. Sammy has a gift card. She's already used 14 of the total value, which was $30. She has a $30 gift card for Hanukkah or Kwanzaa or Christmas or something, and she used $14 of that. So we need to write, solve, and graph an inequality. So we have 3 things that we have to do here. You can't just tell me what the answer is. You have to be able to write an inequality. How could you put this situation into an inequality, into an algebraic expression? So she had $30. She's already used $14 of that total value. We have to write and solve an inequality to show how much more she can spend. So let's see, we don't know how much more she can spend, x. We know that the total value is 30. So $14 she's already spent, plus some amount that we don't know, has to be $30. So some amount plus 14 has to be $30. However, they could spend less than 30. They don't have to spend exactly 30. If we wrote this equation, we could figure out what's the most that she could spend. Right? We could figure out that she could spend $16. That's how much she could spend. But she could spend $2. Right? I mean, you could spend $2 out of that 30. That would still be okay. You can do that. Which means that x could be 2. 2 plus 14 would still be less than that $30. She could spend $10. 10 plus 14, she could do that. She could spend $24. So she could spend a lot of different money, a lot of different amounts. So we have to be able to write this as an inequality. We could say that it's either going to be this or it's going to be this, right? One or the other. And so let's try one and see what happens. Let's say it this way. X plus 14 is less than 30. Let's see what happens. If I spend, or if I solve this, inequality, if I minus 14 from both sides, I'm going to get that x is less than 16. Can she spend less than $16? Yeah. If she spent $1, one more dollar, that would be okay. That would be less than $30. She couldn't spend more than $30. If we wrote the inequality the other way, if we said this, x is greater than 16, that would be wrong. If she spent $20 more, if x was 20, 20 plus the 14 she'd already spent would be $34. That's too much. She doesn't have $34 to spend. She only has $30 to spend. And so that inequality would be that x plus 14 is less than 30, which gives us a solution of x has to be less than 16. She could spend anything under $16. However, before I graph that, could she spend exactly $30? If you have a $30 gift card, you can spend exactly $30, which means that she could spend less than 30, or she could spend exactly 30. So she could spend less than or equal to $16 and still be okay. Let's graph that. Let's see what that looks like as a graph. Now, I told you before you could pick whatever scale you want, and that's true unless you go negative. She can't spend negative money on this gift card. It doesn't say that you can add money to the gift card. You can't spend negative money, which means that you can't go by 50s. You couldn't go 16 and then negative 44 and then negative 94. You couldn't go negative with this scale. And so pick a scale that matches with the situation. I'm going to go by ones. If I graph it then, she could spend exactly $16 and still be okay. 16 more dollars plus the 14 she already spent, exactly 30. Or she could spend less than that. Like you do, maybe give this one a try on your own. And I'm already way over time. So give this one a try and try these four on your own. And we'll talk about this word problem here, about Sarah's age group and the number of milligrams per day that she can consume, and these four on your own. And then we'll do some more problems in class tomorrow.